Hey everyone, welcome to this explainer. Today we're jumping into a real architectural masterclass on optimizing your cloud costs. Whether you're an AWS beginner, a seasoned cloud engineer, or a solutions architect gearing up for certification, you are exactly where you need to be. Okay, let's dive into this. We're going to take a magnifying glass to AWS EC2 Pricing Models and figure out exactly how to slash your compute bill without breaking your workloads.
Let me ask you a question. Why are you paying on-demand prices for servers that have literally been running continuously for years? If you manage EC2 fleets across multiple AWS accounts, you've probably had this exact question thrown at you during a FinOps review. It's an incredibly relatable but absolutely massive, expensive mistake. Choosing the wrong pricing model quietly inflates your cloud bills and wastes thousands of dollars.
So, here's our game plan for today's masterclass. First, we'll look at the cloud cost dilemma. Then, we'll cover core compute commitments, followed by specialized compute for those tricky edge cases. After that, we'll walk through some real-world scenarios, and finally, wrap things up with best practices and a solid decision framework. Right, let's kick things off with Section 1, the cloud cost dilemma, or what I like to call the on-demand trap. This is exactly where companies accidentally hemorrhage money in the cloud. You know the drill. Let's walk through exactly how this on-demand trap springs. Step 1. An application gets deployed. Maybe it's a brand new feature and the team genuinely has no idea what the traffic patterns will look like yet. Totally fair, right? But then Step 2 happens. The EC2 instances are just left to run continuously, 24/7, which leads directly to Step 3. Your AWS bill drastically shoots up over time. And boom, Step 4. Leadership hits the panic button and suddenly demands cloud cost optimization. Leaving steady-state production workloads on-demand is literally the single most common way people waste money on AWS. So, how do we actually fix this? That brings us to Section 2, Core Compute Commitments. Let's look at the foundational tools AWS gives us to pull those costs back down to earth.
When we lay out the commitment timeline, you get this really wide spectrum. Way over on the far left, you've got the 60-second minimum for on-demand, or even a 2-minute warning with spot instances. Right in the middle, you're reserving capacity a few weeks ahead of time. And then all the way on the right, you're locking in for 1 or 3 years. The golden rule of cloud economics here is that flexibility always trades off with cost. Basically, the longer and more rigidly you commit, the less you're going to pay.
Let's start with our baseline, on-demand instances. With this, you are paying by the second with a 60-second minimum, and there is zero commitment, none. It gives you the highest flexibility possible, but, you guessed it, at the absolute highest cost. Now, it's perfect for unpredictable workloads, short-lived testing environments, or bursting capacity when things get crazy. But using it as your default for long-term production? Yeah, that's a massive financial mistake.
But what happens when you actually do commit? You can save up to 72%. No joke. That is the maximum discount possible with reserved instances, or RIs, when you lock in a 1 or 3 year commitment. You've got a couple of options here. You can go with a standard RI, which gives you the biggest discount, but locks you tightly into a specific instance family. Or you can choose a convertible RI, which drops the discount to around 54%, but lets you swap instance families mid-term. You can even decide if you want to pay all upfront, partial upfront, or no upfront, basically trading your cash flow for a deeper discount. RIs are fantastic for those ultra-static workloads. Think of a core legacy Oracle or SQL Server database that's just going to sit on the exact same instance type for years. But let's be real, modern cloud architectures are rarely that static, right? And that's exactly why AWS introduced savings plans. Instead of committing to a specific piece of hardware, you're just committing to a specific dollar per hour spend. A compute savings plan is incredibly flexible. It covers different instance families, sizes, operating systems, and even stretches across EC2, Fargate, and Lambda. On the flip side, an EC2 instance savings plan locks you to one instance family in a specific region, but it's flexible on size and gives you a chunkier discount. Honestly, savings plans have pretty much replaced RIs for most modern teams, because having that flexibility to shift workloads around is totally worth the slight dip in the discount.
All right, moving right along to Section 3, Specialized Compute. Now we're getting into edge cases, strict compliance, and some pretty extreme cost savings.
Okay, how does a 90% discount sound? Because that's exactly what you can get with Spot instances. Spot lets you tap into spare AWS capacity at deeply, deeply discounted rates. But there is a catch. AWS can reclaim that capacity from you with just a 2-minute warning. Because of that sudden interruption risk, you should absolutely never use Spot for stateful workloads that can't handle being abruptly shut down. It is strictly for stateless, fault-tolerant, or checkpointable work. We're talking batch jobs, CI/CD runners, machine learning training, or big data processing.
Now what if you need hardware isolation? Sometimes you literally need a physical boundary around your compute. A dedicated host is an actual physical server dedicated entirely to you. You get full control over instance placement, which makes it perfect for bring-your-own-license scenarios. Think legacy Windows Server or SQL Server Enterprise licensing that's tied to physical CPU cores. A dedicated instance, on the other hand, means the hardware is isolated to just you, but you don't get that placement control. You typically use this for really strict compliance requirements, like in healthcare or finance, where you need that physical isolation, but you don't want the operational headache of managing the host yourself. Let's shift gears into Section 4, Real-World Scenarios. It's time to move from the theory to seeing how an experienced solutions architect actually uses these models in the wild.
And this brilliantly illustrates how all 7 of these pricing models stack up against each other. When you look at a full comparison matrix like this, you really see that constant tug-of-war between cost, flexibility, and commitment. Here's the secret. Most production accounts don't just pick one of these, they blend them. They'll use savings plans or RIs to cover their 60 to 80% steady-state baseline. Then they use on-demand to handle unpredictable burst loads. And finally, they sprinkle in Spot for their batch or stateless work. Let's look at how this plays out in some specific scenarios.
Take Scenario 1, nightly video processing. This is a textbook use case for Spot. The architect breaks the transcoding jobs into checkpointed chunks and runs them on a highly diversified Spot fleet spread out across 5 different instance types. If AWS pulls the plug on one instance with that 2-minute warning, no big deal, the job just resumes somewhere else. By designing the system to handle interruptions gracefully, they are slashing their costs by roughly 70 to 90% compared to on-demand.
Scenario 2 is a classic, an e-commerce platform gearing up for a huge Black Friday sale. The absolute last thing they can afford on launch day is an insufficient capacity error. So, 3 weeks prior to the event, they use a capacity reservation to guarantee their compute space in a specific availability zone. There's no long-term commitment here, but they do pay the on-demand rate whether they actually spin up the instances or not. And here's a pro tip. To optimize this, they can actually layer a savings plan right on top of that reservation to get a discount on it.
Scenario 3, we've got a SaaS platform with a highly modernized workload. Month to month, their compute shifts around between EC2, containerized Fargate tasks, and serverless Lambda functions. A compute savings plan is basically the holy grail of architectural choices here. The discount mathematically follows the workload wherever it happens to land, meaning they get massive flexibility without giving up their savings.
All right, let's bring it all home with Section 5, Best Practices and Decisions. I want to leave you with an actionable framework so you can stop wasting money today. Okay, rapid-fire FinOps best practices, let's go. First, and this is absolutely crucial, right size before you commit. Use AWS Compute Optimizer. If you commit to a massively oversized instance, you are literally just locking in your own waste. Second, default to compute savings plans over RIs unless your fleet is 100% static. Third, layer your commitments gradually as your usage stabilizes. Don't go buying 100% all at once. For Spot, diversify your instance types in your AZs to minimize disruption. Also, make sure you're purchasing your discounts centrally under AWS organizations so they apply across all your linked accounts. Tag absolutely everything so you know who is spending what. And lastly, seriously evaluate Graviton ARM instances. They regularly yield 20 to 40% better price performance, and yes, they are completely compatible with all these pricing models. To make all of this super simple, let's walk through a basic mental decision flowchart. Just ask yourself a few questions. Is the workload temporary or totally unpredictable? If yes, use on-demand. Does it run continuously? Savings plan. Do you need absolutely guaranteed capacity for a big event? Capacity reservation. Can the workload survive being interrupted? Spot. Does it strictly require physical hardware isolation or BYOL? Dedicated. If you just follow this simple routing logic, you'll route any future workload to the most cost-effective model every single time.
But as we all know, real-world architecture is rarely perfectly clean. So I'll leave you with this. Have you run into a scenario where the textbook pricing model didn't quite fit your workload? Architecture is all about making trade-offs, and optimizing cloud costs is this ongoing, fascinating puzzle. I really hope this masterclass has empowered you to look at your AWS bills and your EC2 fleets with a much sharper, more strategic eye. Until next time, keep optimizing.